ഒരു മിനിറ്റ് നീ ചേച്ചി. So last class we started. Good evening all. Geo. Come on. Good evening all. Last class we started AC. We have seen total value of AC over a complete cycle is 0. So we are going forward. RMS value. It is a DC equivalent of AC that would produce same heating effect as that of AC. Then we have seen AC applied to resistor, AC applied to capacitor, AC applied to inductor, right? Then phasor diagram graphical representation. Then power of an AC derivation. There was a confusion at this stage, but still I completed. Power equal to ERMS, IRMS, cos phi. And cos phi is called what? Power factor. In resistor, phi is what? 0 degree. In inductor and capacitor, phi is equal to 90 degree. I hope it is clear. So repeat. Okay. Next point. Wattless current. Wattless current. What is a wattless current? When current passes through inductor and capacitor, phase difference between EMF and current is 90 degree. So phi is equal to 90 degree. Cos 90 is equal to what? Phi equal to 90 degree. Power factor cos phi is equal to cos 90 is equal to 0. Power consumed equation is what? Power consumed P is equal to ERMS IRMS into cos phi. Since cos phi is equal to cos 90 equal to 0, power consumed will be 0. Power consumed will be 0. That is, current flow through inductor and capacitor does not result in any wattage. Such currents are called wattless current. So what is wattless current? When current passes through inductor and capacitor, I am writing HATT, sorry. WATT. Sorry for that. It should be WATT. When current flows through inductor and capacitor, phase difference between EMF and current is what? 90 degree. That is, phi is 90 degree. Cos 90 is what? 0. So power consumed will be what? 0. So even though current flows, that current flow does not result in any wattage. Such currents are called what? Wattless current. Any doubt? It's a very important question. It's a very, very, very important question. Please note it. Any doubt? Note the wattless current വളരെ important ആട്ടോ. Sir, I didn't get it. ദേവിക. മോളെ ദേവിക. ഇൻഡക്ടറി കോഡിങ് കപ്പാസിറ്ററി കോഡിങ് കറണ്ട് പോകുമ്പോൾ എ സി കറണ്ട് ഫ്ലോ ചെയ്യുമ്പോൾ വാട്ട് ഈസ് ദ ഫേസ് ഡിഫറൻസ് ബിറ്റ്വീൻ ഇ എം എഫ് ആൻഡ് കറണ്ട് 90 ഡിഗ്രി. So what is power factor? Power factor is cos phi. Cos phi is what? Cos 90, that is 0. So what is power consumed? ERMS, IRMS, cos phi. Here cos 90 is what? 0. So power consumed will be what? 0. So what is the unit of power? Watt. So what happens in inductor and capacitor? Normally when current passes through a device, that device will consume power and there will be a wattage or a power rating. But in inductor and capacitor, even though current flows, that current flow is not creating any wattage. So we call the current which flows through inductor and capacitor as wattless current because that current flow does not result in any wattage. മനസ്സിലായോ? ഇവിടെ നെക്സ്റ്റ് ക്വസ്റ്റ്യൻ. Why choke coil is preferred over resistor? Remember, both choke coil and resistor are used to reduce current. Choke coil is an inductor. Choke coil is an inductor. When current passes through an inductor, the phase difference between EMF and current is 90 degree. So power factor cos phi is equal to cos 90 is equal to 0. Power factor cos phi is equal to cos 90 is equal to what? 0. Hence, power consumed will be 0. Will be 0. Just now we have written the same line. But in resistor, phase difference between EMF and current is 0 degree, phi equal to 0, cos 0 is equal to 1. So power equal to ERMS, IRMS, cos phi. Here cos phi is equal to 1. So power equal to ERMS, IRMS, that is, there will be maximum power loss. There will be maximum power loss when we use resistor to reduce current. Use resistor to reduce current. Here power equal to what? ERMS, IRMS, cos phi. Cos phi is equal to 0. So power consumed equal to 0. Doubt now? Any doubt? So that is the reason why we prefer choke coil over resistor. Because to reduce power, we can use both choke coil and resistor. What is the advantage of using choke coil? Choke coil is an inductor. Inductor phase difference is what? 90 degree. Cos 90 is what? 0. So power consumed by inductor will be what? 0. But if you are using resistor to reduce current, there will be maximum power loss. So it's better to use what? Inductor. That is choke coil. Doubt now? Yeah. എല്ലാവരും നോട്ട് ചെയ്തോ? നോട്ട് ചെയ്തോ? ഓക്കെ. നെക്സ്റ്റ് Last class we had discussed about AC applied to resistor. In a resistor, EMF and current are in phase. In an inductor, EMF leads ahead of current by 90 degree or current lags behind EMF by 90 degree. In a capacitor, current leads ahead of EMF by 90 degree or EMF lags behind current by 90 degree. Now, next is a very important topic, LCR circuit. It's a very important topic. In an LCR circuit means there will be inductor, capacitor and resistor. This circuit called LCR circuit, or some teachers call it series LCR circuit. LCR. What is the EMF? E equal to E0 sin omega t. This is the instantaneous EMF which we are applying. L is inductor. In an inductor, who is leading? Voltage across inductor leading and current lagging by an amount 90 degree. In a capacitor, who is leading? Current leading, voltage across capacitor lagging. In a resistor, both voltage and current are in the same direction. Now, what is voltage across inductor? Voltage means current into resistance. And we know that current into resistance offered by the inductor is what? Inductive reactance XL. What is the voltage across capacitor? Current into resistance offered by the capacitor, which is capacitive reactance. What is voltage across resistor? Current into resistance. Current into resistance. Any doubt in the figure? AC applied to capacitor I equal to I0 sin omega t plus pi by 2. It is omega t plus pi by 2. I equal to I0 sin omega t plus pi by 2. Okay, Akash. Any doubt here in this figure? Any doubt in this figure? Here it is V suffix L. It is V suffix C voltage across capacitor, V suffix L voltage across inductor, V suffix R voltage across resistor. Any doubt? Yeah. Please note this figure. Figure note data. നോട്ട് ചെയ്താ വരച്ചെടുക്ക് കേട്ടോ വരച്ചെടുക്കേ ഇത് വരച്ചെടുക്ക് വരയ്ക്കേട്ടാ ഇത് വരയ്ക്ക് ആകാശ് AC applied to capacitor E equal to E0 sin omega t, I equal to I0 sin omega t plus pi by 2, because in a capacitor current leads ahead of EMF by 90 degree. All of you noted? Next, all of you drawn the figure, right? Next is phasor diagram. Phasor diagram of LCR circuit. Phasor diagram of LCR circuit. This is the phasor diagram X, Y. I am drawing voltage across resistor in this direction. So current in the same direction. Now I know the voltage across capacitor will be 90 degree behind the current, because in capacitor voltage leads behind current by 90 degree, or current leads ahead of voltage or EMF by 90 degree in capacitor. But what about inductor? Voltage across inductor is what? 90 degree ahead of voltage, ahead of current. See, I am taking current as the base case scenario. Why I am taking current as the base case? Because it is a series LCR circuit. So current will be same. So voltage across capacitor is 90 degree behind this current. Voltage across inductor 90 degree ahead of current. Because we know that in an inductor voltage leads ahead of current by 90 degree, or current lags behind voltage EMF by 90 degree. Now, if this is plus VC in this side, so this side will be what? Sorry, I am having severe cold. This side it will be minus VC. I hope you got the point. If this side is plus VC, then this side will be what? Minus VC. Any doubt? If this side is plus VC, this side will be what? Minus VC. So what is the in-effect voltage? VL minus VC. What is the in-effect voltage? VL minus VC. Any doubt? If this side is plus VC, this side is minus VC. So what is the in-effect voltage? There is already VL and VC is opposing VL because it is minus VC. So what is the in-effect voltage? VL minus VC. I hope all of you got that point. This is plus VC, then this will be what? Minus VC. There is already plus VL and opposing that plus VL there is minus VC. So what is the in-effect voltage? VL minus VC. I am repeating that because for some students it's not easy to understand. This is plus VL and this is plus VC. So this side it will be minus VC. So in-effect voltage at this side is what? VL minus VC. Now let's see. This is the resultant EMF. What is this? Resultant EMF. For understanding that, I am drawing a parallelogram method, you can say, or triangular law of attribution. This is the EMF or hypotenuse. So if this is VL minus VC, then this also will be what? VL minus VC. Because this side will be equal to this side, no? And the this is what? Altitude. This is base. What is base? Voltage across resistor. What is the angle between resultant EMF and current? This angle is phi. What is the angle between resultant EMF and x-axis? Omega t. Angle between EMF and current phi. Angle between resultant EMF and x-axis is what? Omega t. Any doubt? മക്കളെ അത് മനസ്സിലായോ? ഇത് വരയ്ക്കാൻ പഠിക്കണം. ഇത് വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. ഇത് വരയ്ക്കാൻ പഠിക്കലാണ് ഏറ്റവും ഇമ്പോർട്ടൻ്റ് ആയിട്ടുള്ള കാര്യം. ഇത് വരയ്ക്കലാണ് ഇതിന്റെ പ്രധാനപ്പെട്ട കാര്യം. ഇത് വരയ്ക്കാൻ പഠിക്കണം. See, by simply looking at this figure, everybody will say they understood everything. But it is not easy to draw this figure at exam time. So you have to draw minimum 5 times. VC is what? This side is what? VL minus VC. This is the in-effect voltage here, VL minus VC. Total EMF is what? E. VC is there, voltage across capacitor. Why I am subtracting VC? Because voltage across capacitor is in the opposite direction of VL. So by vector addition, if this is VL and this is VC, this side will be what? VL minus VC. That is the in-effect voltage there. And suppose capacitor voltage is 100 and inductor voltage is 300. So what will be the in-effect voltage? 300 minus 100. It will be what? 200. Any doubt? All of you, please draw the figure. Please draw the figure. Then only I am proceeding. I am taking more time to complete this topic because this is the most important topic of this chapter. LCR circuit and phasor diagram of LCR circuit. Please take out your notebook. Please draw the figure. It's very, 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 very important. നോട്ട് ചെയ്താ എല്ലാവരും വരച്ചാ? Please draw phasor diagram. Yeah, all of you noted. I hope all of you noted. Now let's start. What is E square? E square is the hypotenuse square. Hypotenuse square is equal to what? Base square, voltage across resistor square, plus altitude square, voltage across inductor minus voltage across capacitor, the square. So E square equal to VR square plus VL minus VC the whole square. So E square equal to, instead of VR I can write what? I into R the whole square, plus instead of VL I can write what? IXL, instead of VC IXC the whole square. So E square equal to I squared R square plus I square into XL minus XC the whole square. So E square equal to I square into R square plus XL minus XC the whole square. So E square by I square is equal to R square plus XL minus XC the whole square. E square by I square is equal to Z square. So Z square equal to what? R square plus XL minus XC the whole square. So Z is equal to what? Root of R square plus XL minus XC the whole square. This is the Z here. Z is called impedance. Z is called impedance. Impedance is the, what is impedance? See, in E square by I square. E square means what? Total EMF square. Divided by I square is what? Total current. What is total EMF by total current? It is the impedance. So here Z is called impedance. Why it is called impedance? Because EMF by current is what? Resistance. Impedance is the overall blocking against electric current. Overall blocking against electric current. What is impedance? Overall blocking against electric current. Unit ohm. Unit of impedance ohm. Unit is ohm. So do remember, unit of inductive reactance XL, capacitive reactance XC, resistance R, impedance Z is what? Ohm. All of these physical quantity have the same unit ohm. So what is impedance? Overall blocking against electric current. Why we are calling impedance? Because there will be blockage from resistor, blockage from inductor, blockage from capacitor. So the overall blocking is called what? Impedance. No one. Sir, നമുക്ക് VC minus VL use ചെയ്യാൻ പറ്റും. See, I am writing Z equal to root of R square plus XL minus XC the whole square, since I am assuming XL greater than XC or inductive reactance greater than capacitive reactance. If in some case capacitive reactance will be greater, so R square XC minus XL the whole square. So what is the equation? XC greater than XL. If XC greater than XL, it is XC minus XL the whole square. Naveen Kumar, is it clear? If inductive capacitive reactance greater than inductive reactance, your formula should be XC minus XL the whole square. ഈ വെക്ടറിന് ലാർജ് ആംഗിൾ വെച്ച് വരയ്ക്കാൻ പാടുമോ? ഈ വെക്ടറിന് അതെനിക്ക് മനസ്സിലായില്ല. താൻ എന്താ ഉദ്ദേശിച്ചത്? ഈ വെക്ടറിന് ഇത്ര ആംഗിൾ ഉണ്ടാവും. സ്ക്വയർ ചെയ്യുമ്പോൾ ഇഫക്റ്റ് പോകും എന്നൊക്കെ പറഞ്ഞാലും അത് ഫുള്ളായിട്ട് ശരിയാണോ? അല്ല, ഫുള്ളായിട്ട് ശരിയാവുന്നല്ല. നമ്മൾ ഇഫ് യു ആർ ടേക്കിംഗ് പവർ ഓർ ഹീറ്റ്, നോ, then only if you are taking power or heat, then only we can get a value for current. Generally, if you take average of a cycle, your value will be always 0. Generally, when you take an average of a cycle, means that there will be both positive and negative values. So your average will be 0. But when current passes through a circuit, the heating effect will be there. So why I am going for heating effect or power loss? I square is there. So we will get a positive answer. Otherwise, if you are simply taking average, your average current will be always 0 in a cycle. The same thing, Jishnu, we have done in first year also. In kinetic theory of gases, we have seen gas molecules are having different velocities. If 10 gas molecules are moving in the left side, 10 will be moving to the right side. So in kinetic theory of gases chapter also we had taken what? RMS velocity, root mean square velocity, in order to get a definite value for velocity. Please note it down. All of you, please note it down. Please note it down once. അതന്നെ അടുത്തത് സാധനം എടുക്കും. നോട്ട് ചെയ്താ Please note it down. Remember, impedance is the overall blocking against electric current. Sir, അപ്പോൾ ഇംപിഡൻസ് എന്നത് കപ്പാസിറ്റർ ആൻഡ് ഇൻഡക്ടർ ആൻഡ് റെസിസ്റ്റർ കമ്പൈൻ ചെയ്ത് ഓഫർ ചെയ്യുന്ന റെസിസ്റ്റൻസ്. യെസ്. നവീൻ കുമാർ, വെൽ എക്സ്പ്ലെയിൻഡ്. I think that line I was supposed to say. You have explained it very well about impedance. Now, Naveen Kumar, one more thing you have to note that inductive reactance and capacitive reactance are opposite direction. So, in impedance, the difference between inductive reactance and capacitive reactance is added since they are in the opposite direction. Any doubt? മനസ്സിലായ നവീൻ കുമാർ? നവീൻ മനസ്സിലായോ? ഹലോ നവീൻ, പ്ലീസ് റെസ്പോണ്ട്. അതേഴ്സ് ഫിനിഷ് ചെയ്താ? ഫിഗർ വരച്ച? ഇംപിഡൻസ് ഡിറൈവ് ചെയ്താ? നവീൻ ഒന്നുമില്ലടാ, നീ എഴുതി തന്നെയാണ്. ഞാൻ പറഞ്ഞതെന്ന് ഇത്രേ ഉള്ളൂ. വാട്ട് ഈസ് ഇംപിഡൻസ്? നീ പറഞ്ഞത് തന്നെ. ഒരു LCR സർക്യൂട്ടില്, ഒരു AC സർക്യൂട്ടില് ഇൻഡക്ടറും കപ്പാസിറ്ററും റെസിസ്റ്ററും എല്ലാം ACനെ ബ്ലോക്ക് ചെയ്യാം. ഇവരുടെ എല്ലാവരുടെയും കൂടിയിട്ടുള്ള ടോട്ടൽ ബ്ലോക്കിംഗ് അഗെയിൻസ്റ്റ് AC കറണ്ടിനെ വി ആർ കോളിംഗ് ഇംപിഡൻസ്. But one interesting thing is that the inductive reactance and capacitive reactance are in the opposite direction. So we always take the difference between inductive reactance and capacitive reactance. Why? Because they are in the opposite direction. So Z equal to root of R square plus XL minus XC the whole square. കഴിഞ്ഞോ? എല്ലാവരും നോട്ട് ചെയ്താ? നോട്ട് ചെയ്തില്ലേ? ഓക്കെ. No, the previous figure only. Now, I am considering this triangle. I am drawing this triangle separately. This is the EMF. This is the voltage across resistor. And this side is what? VL minus VC. And this is what? Phi. So what is tan phi? Tan phi is equal to opposite side by adjacent side. What is opposite side? VL minus VC. What is adjacent side? VR. What is VL? IXL. What is VC? IXC. And what is VR? I into R. So tan phi is equal to, if you take I common, XL minus XC by I into R. So I got cancelled. Tan phi is equal to what? XL minus XC by R. Phi is equal to what? Tan inverse XL minus XC by R. It's equation for phi. Tan inverse XL minus XC by R. Now what is cos phi? Cos phi is equal to adjacent side by hypo. So cos phi is equal to, what is adjacent side here? V suffix R. What is hypotenuse? Total EMF. V suffix R is what? Current into resistance. Total EMF is what? Current into total resistance. That is the impedance. What is total EMF? Current into total resistance. That is impedance. So I gets cancelled. So power factor cos phi, we have one more equation. Power factor cos phi is equal to what? R by Z. Doubt enough? Previous equations, LCR circuit മാത്രം valid ആണോ അതോ? No, only for LCR. Only for LCR. So we are seeing tan phi and cos phi now. Yeah. Okay. നോട്ട് ചെയ്താ? അവിടെ ഫീഡാണ്. നോട്ട് ചെയ്താ? എല്ലാവരും നോട്ട് ചെയ്താ? See, this is the most important point about AC chapter, LCR circuit or series LCR circuit. This is very, 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 very important. ചെയ്തെല്ലാവരും? കഴിഞ്ഞോ? Yes, all of you noted. So next is very important point, resonance. Resonance condition. When LCR circuit is under resonance, when LCR circuit is under resonance, inductive reactance is equal to capacitive reactance. Capacitive reactance. XL equal to XC. What is XL? L omega. What is XC? 1 by C omega. That is L omega into C omega is equal to 1. That is omega square LC is equal to 1. So omega square equal to 1 by LC. So omega is equal to what? 1 by root LC. Now we know that omega is equal to 2 pi f. So 2 pi f is equal to what? 1 by root LC. So f is equal to what? 1 by 2 pi root LC. This is a resonance frequency condition. F is equal to 1 by root LC. Reactance. You didn't sit in the last class, Naveen Kumar, last class video. I have explained resistance offered by capacitor, capacitive reactance. Resistance offered by inductor, inductive reactance. So what is the resonance frequency condition? F equal to 1 by 2 pi root LC. Please note down resonance condition, where F is what? Frequency. L is what? Inductance. C is what? Capacitance. Here unit Henry. Capacitance unit Farad. Note ചെയ്യാട്ടോ. Exam class will be there. How many chapters are there for your exam? Onam exam. How many chapters are there for your Onam exam? Only 4 chapters. Okay. That I will discuss. So you want short classes of first 4 chapters, important topics of Onam exam to be covered. You want like that? Then we will see. If you want, I can provide that. No problem. നോട്ട് ചെയ്ത എല്ലാവരും നോട്ട് ചെയ്താ നോട്ട് ചെയ്തു റൈറ്റ്. നെക്സ്റ്റ്, properties of resonance. Properties of resonance. So what is the first property? XL equal to XC. So what will be the impedance? Z equal to root of R square plus XL minus XC the whole square. XL equal to XC. So Z equal to R. Z equal to what? Root of R square. That is Z equal to what? R. So impedance is equal to resistance under what condition? Under what condition? What is answer? Resonance condition. Answer is what? Resonance condition. Then impedance. In resonance, impedance will be minimum. Impedance will be minimum because root of R square, this plus term vanishes during resonance. Yeah, that one short class will be there. Jishnu, I will be trying to put that class as exam oriented one short class before Onam exam. Okay, in resonance, XL minus XC term vanishes because they are equal and opposite. So impedance equal to resistance, that is impedance will be minimum. Unit of impedance is what? Ohm. If that a quantity with the unit ohm minimum means what? Current will be what? Current will be maximum. Current will be maximum. And another point, voltage across inductor will be opposite in phase to voltage across capacitor or phase difference between voltage across inductor and capacitor will be 180 degree. So they cancel. They means voltage across inductor and capacitor cancel with each other. And applied voltage completely drops across resistor. And the applied voltage completely drops across resistor. These are the important points about resonance. These are the important points about resonance. Now, at the resonance, current is limited by resistance only. If that resistance is minimum, also minimum, then current will be maximum. Then current will be maximum. Doubt in the properties of resonance, which is very important. This is very important data. Very important ആണ്. ശരിയാ. ഡൗട്ട് ഉണ്ടോ? Next year, XI, x-axis we have frequency. We got two graph. This for resistor R1, this for resistor R2. Why? This is I0 at the first case. This is I0 at the second case. This stands for omega suffix R. This stands for resonant frequency. Resonant frequency. Resonant frequency. Resonant frequency. R1 R2. This stands for resonant frequency. Okay. Now, which of the resistor have small value? Can anybody say which of the resistor have small value? Can anybody say which of the resistor have small value? Can anybody say which of the resistor have small value? R1. R1 is the correct answer. Here, current for R1 is greater than R2 at what time? At resonance. At resonance. We know that at resonance, current is limited only by resistance. Current is limited only by resistance. Since current is maximum for R1, resistance of R1 should be minimum. Resistance of R1 should be minimum. Resistance of R1 should be minimum. നോട്ട് ചെയ്യാം കേട്ടോ. നോട്ട് ചെയ്യാം കേട്ടോ. Done? Noted? നോട്ട് ചെയ്താ. നെക്സ്റ്റ് അപ്ലിക്കേഷൻസ് ഓഫ് റെസൊണൻസ്. അപ്ലിക്കേഷൻസ് ഓഫ് റെസൊണൻസ് അതിൽ ഫസ്റ്റത്തെയാണ് ഒന്ന് റേഡിയോ ടി വി ട്യൂണിങ്. റേഡിയോ ഓർ ടി വി ട്യൂണിങ്. F equal to 1 by 2 pi root LC. When we tune the radio, C is equal to, what is the formula? Epsilon 0, epsilon R, A by D. When the distance between capacitor plate capacitance vary, we know that F equal to 1 by 2 pi root LC. 1 by 2 pi root LC. When capacitance varies, what happens? Frequency varies. So you will get another channel. Suppose I am listening to 91.9 megahertz Club FM. I don't know what it is. And suppose there is an advertisement going on, I will tune the radio. So what happens when you tune? Distance between capacitor plate varies, then capacitance vary. When capacitance varies, frequency varies. Then you will get another channel. You got the point? ആ പോയിന്റ് മനസ്സിലായോ? അപ്പൊ വേറെ ചാനൽ കിട്ടും. മനസ്സിലായോ? അങ്ങനെയാണ് റേഡിയോ ടി വി ട്യൂണിങ് വർക്ക് ചെയ്യണേ. മനസ്സിലായോ? ആണ് ഫസ്റ്റ് ആപ്ലിക്കേഷൻ. നെക്സ്റ്റ് മെറ്റൽ ഡിറ്റക്ടർ. മെറ്റൽ ഡിറ്റക്ടർ. A metal detector is a LC circuit at resonance. If your body, if a person carries any metal thing, any metal substance, and passes through the metal detector, it will affect the tuning. It will affect the resonance and alarm will be on. See, my mother is having some heart related problem. So she has implanted a pacemaker into her heart. So whenever she goes through metal detector, she carries that doctor's certificate along with her. So whenever she passes, since her body is having metal part, there will be alarm, burster alarm. When the security persons come, she will show her certificate saying that her body is having an implanted metal device for pacemaker. Any doubt? മനസ്സിലായോ? These are the two applications of resonance. അത് മനസ്സിലായോ? മാഷെ പറഞ്ഞത് മനസ്സിലായോ? പനിയാണെന്ന് പറയാം. അമ്മേ അയ്യോ. നോട്ട് ചെയ്താ? എല്ലാവരും നോട്ട് ചെയ്താ? Next question. Next is a problem. There is an inductor and a capacitor and a resistor. Here the voltage is V1, here voltage V2, here voltage V3. Applied voltage is 200 volt. Voltage across inductor 300 volt. Capacitor is also 300 volt. Resistor 200 volt. And suppose there is an ammeter. What will be the values of voltmeter V1, V2 and V3 and ammeter and ammeter. Ammeter is only one. അത് കണ്ടുപിടിക്കണം. Can anybody say the answer? Can anybody say the answer? Answer is very simple. Since the voltage across inductor and capacitor is 300 volt, they will cancel with each other. Because we know that VL and VC are 180 degree out of phase. So what will happen? They will cancel with each other. We know that. So applied voltage completely drops across resistor. Applied voltage completely drops across resistor. So V1 equal to 0, V2 equal to 0, and V3 is equal to what? 200 volt. Any doubt? Why? Because inductor and capacitor voltage and inductor voltage are opposite in direction, phase. So they cancel with each other. So applied voltage completely drops across what? Resistor. So this 300 minus 300, this becomes 0, and applied voltage completely drops across resistor V3 equal to 200 volt. Now current I is equal to what? V by R. Here what is voltage? Ineffective voltage is what? 200 volt. And the resistance is what? Oh, resistance value is given. I forgot to write the resistance value. Resistance is 100 ohm. 100 ohm. So answer is what? 2 ampere is the ammeter reading. Ammeter reading is what? 2 ampere. See, whenever the inductor value and capacitor value are equal, always remember they will cancel with each other, because voltage across capacitor is opposite in phase to voltage across inductor. Any doubt? Any doubt? Doubt എന്നാ? ഇത് ഇമ്പോർട്ടന്റ് പ്രോബ്ലം ആണ് കേട്ടോ. മനസ്സിലായോ? മനസ്സിലായോ? ഇവിടെ ചില കുട്ടികൾക്ക് ഒരു ഡൗട്ട് തോന്നാം, സാറേ ആകെ there is only 200 volt is the applied voltage, then how come the voltage across inductor and capacitor becomes 300 volt? Because you always remember it is an AC source. In AC source 200 volt is what? RMS voltage. But sometimes we know that it may go up to what? 200 into root 2. Because in AC there is a concept called peak voltage. So there is a concept of maximum voltage in AC. So that is the reason why we are getting 300. In DC means the circuit will have 200 only. There will not be any point which has a more voltage. But in AC, you can say the voltage will be varying at a different instance of time. Because AC there is a concept called peak voltage. Always remember that. So that is the reason why even though applied voltage is 200, the voltage across inductor and capacitor is 300. Any doubt? ആ കോൺസെപ്റ്റ് ആലോചിച്ചതുകൊണ്ടാ ചില കുട്ടികൾക്ക് അപ്പൊ തോന്നും അത് ഡൗട്ടാണ്, ക്വസ്റ്റ്യനിൽ തെറ്റുണ്ട് എന്നൊക്കെ തോന്നും ചില നേരത്ത്. അത് മനസ്സിലായോ? അത് ഈക്വൽ അല്ല എങ്കിൽ നമുക്ക് ചെയ്യാൻ പറ്റില്ല. പിന്നെ നമ്മൾ ആ ഇമ്പിഡൻസ് ഒക്കെ കണ്ട് കുറെ പണിയുണ്ട്. അപ്പൊ ഫ്രീക്വൻസി ഒക്കെ തരണം. 200 വോൾട്ട് തന്നിട്ട് കാര്യമില്ല, ഫ്രീക്വൻസി തരണം. ഇമ്പിഡൻസ് Z=√R² + XL - XC² വരണം. അങ്ങനെ കുറെ വർക്ക് ചെയ്യണം. അത് ഞാൻ ചെയ്യാം. അടുത്ത ക്ലാസ്സിൽ വി വിൽ ബി ഡൂയിങ് പ്രോബ്ലംസ്. നെക്സ്റ്റ് ക്ലാസ് വി വിൽ ബി ഡൂയിങ് മോർ പ്രോബ്ലംസ് ഓർ ഓൺലി പ്രോബ്ലംസ് ഓഫ് AC. നെക്സ്റ്റ് ക്ലാസ് ഐ വിൽ ബി ഫിനിഷിംഗ് AC. Next Friday class I will be finishing AC, and next Saturday class I will be doing electromagnetic waves. Next class full of problems, all the problems of AC we will be doing. So please prepare the today and tomorrow yesterday's class. Please have a note. Please by heart all the formulas, because next class we will be doing only problems. Okay, theory part is done. And there is one more section, transformer, that I have already taken along with the electromagnetic induction. So thank you. We are done with AC. Thank you all. Thank you. Good night. Have a happy weekend.